Today, we are going to learn about propellants. A propellant is a mass that is expelled or expanded in such a way as to create a thrust or other motive force in accordance with Newton's third law of motion and propel a vehicle, projectile, or fluid payload. In rocket, it is a chemical substance that undergo combustion to produce pressurized gases whose energy is utilized to move a rocket against the gravitational force of attraction. It is a mixture which contains a fuel that burns and an oxidizer which supplies the oxygen necessary for the burning of the fuel. Now let's see about the principle of operation. In a chemically powered rocket, the engine creates thrust by combustion of the propellant materials to form very hot gases which expand in the combustion chamber and are ejected as a high-speed jet through a nozzle in a rear. In a closed chamber, the gas pressure could be equal in each direction and no acceleration could occur. By providing an opening at the bottom of the chamber, there is no pressure acting on that side but exhaust escape from that end. The remaining component of the pressure produces a thrust on the side opposite the opening using a nozzle increases the force further, in fact, multiplies the thrust as a function of the area ratio of the nozzle because the pressures also act on the nozzle. In addition, the pressures act on the exhaust in the opposite direction and accelerate to a very high speed. This disequilibrium of pressures can be maintained for as long as propellant is added to the combustion chamber. It turns out that the speed of the exhaust of the rocket determines how much momentum increase is created for a given amount of propellant. The faster the net speed of the exhaust in one direction, greater the speed of rocket in opposite direction can become. As the propellant supply decreases, the vehicle becomes lighter and acceleration increases until the rocket eventually runs out of propellant. Consequently, much of the speed change occurs towards the end of the burn, then the vehicle is much lighter. This operational principle stands in contrast to the commonly held assumption that a rocket pushes against the air beneath it. Rockets perform better in space where there is practically nothing behind them to push against because they do not need to overcome air resistance and atmospheric pressure. Now let's see about the parts of the propellant system. The propellant system consists of fuel, oxidizer, pumps and nozzle. Now let's see about the types of propellant. There are 4 types of propellant: solid propellant type, liquid propellant type, cryogenic propellant type and hybrid propellant type. Now let's see about the classification of propellant. The solid is classified into double base and composite, and liquid is classified into monopropellant, bipropellant, and bipropellant is classified into storable and cryogenic. Now let's see about the solid propellant type. In a solid rocket, the fuel and an oxidizer are mixed together into a solid propellant which is packed in a solid cylinder. A hole through the cylinder serves as a combustion chamber. When the mixture is ignited, combustion takes place on the surface of the propellant. A flame front is generated which burns into the mixture. The combustion produces great amount of exhaust gas at high temperature and pressure. The amount of exhaust gas that is produced depends upon the area of the flame front. An engine designers uses a variety of oil shapes to control the change in thrust for a particular engine. The hot exhaust gas is passed through a nozzle which accelerates the flow. Thrust is then produced according to Newton's third law of motion. There are four different types of solid propellant combustion, that is single base propellant, double base propellant, triple base propellant and composite propellant. But in rocket we only use double base propellant and composite propellant. A double base propellant, it consists of nitrocellulose with nitroglycerin or other liquid organic nitrate explosive added. Stabilizer and other additives are also used. Nitroglycerin reduces smoke and increase the energy output. Double base propellant are used in rockets, cannons and small arms. Composite propellant. Composite contains no nitrocellulose, nitroglycerin, nitrocodenine or any other organic nitrate. Composite usually consists of a fuel such as metallic aluminum, a binder such as a synthetic rubber and an oxidizer such as ammonium perchlorate. Composite propellants are used in large rocket motors. It also consists of polyurethanes and polybutadienes as fuel and nitrate and chloride salt as oxidizer. Now let's see about the liquid propellant type. In 1926, Robert Goddard tested the first liquid propellant rocket engine. His engine used gasoline and liquid oxygen. He also worked on and solved a number of fundamental problems in rocket engine design, including pumping mechanism, cooling strategies, and steering arrangements. The common liquid rocket is bipropellant. It uses two separate propellant, a liquid fuel and liquid oxidizer. These are contained in separate tanks and are mixed only upon injection into the combustion chamber. They may be fed to the combustion chamber by pumps or by pressure in tanks. Propellant flow rate must be extremely large for high thrust engines, often hundreds of gallons per second. Pumping feed system may require engine delivering several thousand horsepower to drive the pumps. This power is usually developed by a hot gas turbine supplied from a gas generator, which is actually a small combustion chamber. The main rocket propellant can be used for the gas generator. Common propellant combination used for liquid propellant rockets are red fumic nitric acid and kerosene, red fumic nitric acid and dimethyl hydrazine, and liquid oxygen and kerosene, liquid oxygen and liquid hydrogen, liquid oxygen and ethanol, hydrogen peroxide and alcohol, chlorine pentafluoride and hydrazine, and common monopropellant used for liquid rocket engines are hydrogen peroxide, hydrazine, red fumic nitric acid. Now let's see about the cryogenic propellant type. A cryogenic rocket engine is a rocket engine that uses a cryogenic fuel and oxidizer, that are the gases which are liquefied and stored at very low temperatures. Rocket engine need high mass flow rate of both oxidizer and fuel to generate a sufficient thrust. Generally, oxygen and low molecular weight hydrocarbons are used as oxidizer and fuel pair. The combination of liquid oxygen and liquid hydrogen offers the highest energy efficiency for rocket engines that need to produce large amount of thrust. This fuel do not need any ignition system. Cooling and compressing gases into liquids can vastly increase their density and make it possible to store them in large quantities in smaller tanks. Supercooled gases are stored at a temperature lower than their freezing point. Now let's see about the working of the cryogenic propellant. Fuel and oxidizer from the external tank enters the orbiter. Orbiter's main propellant system feed lines the fuel and oxidizer. Each branch out to engine and oxidation system provides regular supply of liquid oxygen, and hydrogen fuel system provides regular supply of liquid hydrogen. The pump pumps the fuel and the oxidizer into the combustion chamber. It generates extremely high pressure. Pump fuel and oxidizer are mixed, ignited and burned in combustion chamber to create a high pressure and high velocity of hot gases. The accelerated hot gases further and produce thrust. Now let's see about the hybrid propellant type. Rocket system in which one component of the propellant is stored in liquid phase while the other is stored in solid phase are called as hybrid propellant rockets. Mostly liquid oxidizer and solid fuels are used. Now let's see about the working of the hybrid propellant. In this, oxidizer is injected into the pre-combustion chamber of vaporization chamber upstream of primary fuel grain. The fuel grain, which contains numerous axial combustion ports which generate fuel vapor to react with the injected oxidizer after mixing chamber in kept for complete combustion of fuel and oxidizer before exiting the nozzle. Hypergolic fuels used are hydrogen, monomethyl hydrogen, unsymmetrical dimethyl hydrogen. Oxidizer mainly used is nitrogen peroxide and nitric acid. Now let's see about the pros and cons of solid and liquid propellant. Positive aspects of solid fuel. Solid fuels are more temperature stable and provide for greater storage stability over long period of time. Solid fuels can also be efficient at generating thrust and in generally or a simple design with far fewer parts than a liquid fuel engine. The chemical used in manufacture of the propellants are also rather cheap. Advantage of liquid propellant fuel. Liquid fuel engines are now becoming more reusable with little refurbishment required before reflight. In solid fuel engine, the entire casing must be refurbished before it can be reused. Recovering of the liquid fuel engine may be as simple as landing it using thrust, which is impossible with the solid fuel engine, which has to recover by parachute and usually landed in water to prevent it from crushing. Exposure to seawater increases the amount of refurbishment needed. Reloading solid fuels requires specialized facilities, whereas liquid fuel potentially only require a tank, a pump, and a hose. Only rocket manufacturers who want to try to save money use the cheaper but less useful solid fuel. Usually, in fall-away booster or a low-altitude first stage. Liquid fuel provides more control, flexibility, and reusability, and more potential than just for launching, but as propulsion to other planets and the ability to be refueled in space. So that's it for today. Thank you.